I've covered TeamPCP 3 times now on this channel. First, it was Trivy, and then Axios, and then it was the wave that hit npm, PyPI, and Docker Hub simultaneously. And each time, I said the pattern was worth watching. Yesterday, they hit TanStack, and this one is different in ways that matter. If you're not familiar, TanStack is a collection of open source JavaScript libraries that are used by millions of developers, and the most popular one is TanStack Query. If you've built anything with React in the last few years, there's a good chance that you've used it. TanStack Router alone gets 12 million weekly downloads. These aren't niche tools, they're foundational infrastructure for modern web development. And on May 11th, between 7:20 and 7:26 UTC, that's a 6-minute window, 84 malicious versions were published across 42 packages in the TanStack namespace. By the end of the day, the campaign had spread to over 170 packages across npm and PyPI. Over 518 million cumulative downloads and over 400 repositories were created using stolen credentials as part of the attack. This is the largest wave of mini Shai-Hulud yet. So here's what makes this attack different from anything that TeamPCP has done yet. They didn't steal credentials, and they didn't socially engineer a maintainer. They hijacked TanStack's own legitimate release pipeline and used it to publish the malicious packages themselves. So here's the chain. On May 10th, an attacker created a fork of the TanStack router repository. They renamed it something that wouldn't appear in fork-listed searches, and then they opened a pull request against the main repo. A pull request, or a PR, is how developers propose changes to a codebase on GitHub. It was a draft PR with an empty-looking diff titled WIP Simplify History Build. That PR triggered a pull request target workflow, and this is a known dangerous GitHub action pattern called a pwn request. It runs with repository level permissions even on code from a fork. The attacker's fork code poisoned the GitHub Actions cache with a malicious pnpm store. And just a quick explainer about what that means, pnpm is an alternative to npm for managing JavaScript packages. Instead of each project having its own copy of every dependency, pnpm keeps one central store that all projects share. It's faster and more efficient, but it also means that if you corrupt that central store, every project that pulls from it gets the malicious version automatically. And that's exactly what happened here. When legitimate maintainer PRs were later merged to main, the release workflow restored that poisoned cache. And then here's the clever part. Attacker-controlled code extracted OIDC tokens directly from the GitHub Action Runner's process memory. If you're not familiar, OIDC stands for OpenID Connect. These are short-lived authentication credentials that GitHub Action uses for trusted publishing. And here's how the extraction works. On Linux, every running process has a file at proc/processid/mem that represents that process's memory. With the right permissions, you can read another process's memory directly from that file, and the GitHub Actions runner holds OIDC tokens in memory during the workflow execution. The attacker's code running inside the same runner environment had enough permissions to read the runner's memory and pull the token straight out of it. The attacker used those stolen tokens to publish the malicious packages as if they were the legitimate TanStack release pipeline. No npm credentials stolen, the publish workflow itself wasn't compromised, the packages were published by TanStack's own trusted identity. Now here's a detail that I want you to pay close attention to. The malicious package carried a valid SLSA Build Level 3 provenance attestations. SLSA here isn't about tortilla chips. It's the acronym for supply chain levels for software artifacts, pronounced SLSA. SLSA provenance is a cryptographic certificate generated by SigStore that's designed to verify a package was built from a trusted source. It's one of the primary ways that the security community has been recommending that you verify packages are safe. The attacker used the stolen OIDC tokens with the legitimate SigStore stack to produce valid attestations for malicious packages. This is the first documented npm supply attack where the malicious packages are cryptographically indistinguishable from legitimate ones by provenance attestation. And Step Security put it clearly, SLSA provenance confirms which pipelines produced the artifact, not whether the pipeline was behaving as intended. And now, valid provenance no longer guarantees safety. And there's one detail in this attack that I want to address very specifically. The malware installs a persistent monitoring daemon on infected machines, and it checks GitHub every 60 seconds to see if the stolen tokens are still valid. If it detects that a token has been revoked, it attempts to recursively delete your home directory. So here's the critical thing. If you ran any affected TanStack packages on May 11th, do not immediately revoke your tokens. I know that sounds counterintuitive, but if the malware is running on your machine and it sees a token get revoked, it may try to wipe your home directory before you can even stop it. The right order of operations is this. First, isolate the machine from the network, disconnect it. Then image the drive for forensic purposes if you need to do that. Then rotate credentials from a clean machine. Then address the infected system. Be very sure that you don't revoke tokens on a machine that may still be running the malware. If you ran any npm install or CI pipeline on May 11th, here's what to look for. So check your log files for any TanStack packages. The confirmed clean families are TanStack Query, TanStack Table, TanStack Form, TanStack Virtual, and TanStack Store. Everything else in the TanStack namespace that was published between 720 and 726 UTC on May 11th should be treated as suspect. Also, check your GitHub Actions run logs for anything that ran after May 11th at 7:20 p.m. UTC. Look for unexpected npm publish events and outbound connections to git-tanstack.com or api.masscan.cloud. Block these at your DNS or proxy level right now. Blocking these domains there means that nothing on your network can reach them. Also, run npm token list and look for any tokens that you don't recognize. And if you use Mistral AI's npm or PyPy packages, rotate your credentials. The Mistral AI/Mistral AI package was also compromised as part of this campaign. If affected packages ran in your environment, treat the machine as compromised. This means do a clean reinstall of your CI runners, rotate credentials from a separate clean machine in the order recommended by socket. This means npm tokens first, then GitHub personal access tokens, then AWS credentials, then Vault tokens, then Kubernetes service account tokens. So let's take a step back and look at what TeamPCP has built over the past few months. March of 2026, there was Trivy and credentials were stolen from thousands of CI pipelines. In April of 2026, there was the Bitwarden CLI and GitHub Actions attack. And in May of 2026, there's TanStack, the same worm toolchain, but now it can produce cryptographically valid provenance attestations for malicious packages. Each wave builds on the previous one, and each wave is more sophisticated than the previous one as well. There's also a detail in this attack worth noting carefully. One of the malicious commits was authored under the identity Claude at users.noreply.github.com, impersonating the Anthropic Claude GitHub app. The intent was to make the commit look like the legitimate AI-assisted automation, but that wasn't the case at all. Anthropic's Claude didn't do any of this. The pattern that's emerging is that TeamPCP is specifically targeting the trust mechanisms that the security community relies on. We're talking version tags, OIDC tokens, SLSA provenance. Each attack exploits whatever the current best practice is for verifying software is safe. And that is a much harder problem to solve than finding and patching vulnerabilities. So if you ran TanStack packages on May 11th, treat the environment as compromised and work through the steps that I covered earlier. If you didn't, the practical steps are still worth doing. Block those domains and audit your GitHub Actions workflow for the pwn request pattern. And understand that valid SLSA provenance no longer guarantees that a package is clean. As per usual, all of the sources for this video are linked in the video description, including the socket campaign tracker for the most current affected packages list, as this is still developing. But I think with all of that said, I'm going to wrap this up. I want to thank you guys for spending a few minutes of your day with me here today. I'll talk to you in the next video.